inside the Gemini application. There's also some additional update where Gemini Ultra is supposed to transition into long context system for consistent multi-step workflows. The subscription tiers may also change and shift towards advanced, pro, and ultra structure. There's also supposedly a new memory feature called Team Food. It's supposed to improve how Gemini uses your past chats and long-term context. One of the biggest pain points with working with AI right now is probably how well the model remembers your past context and all your information to help you with your future prompts. For example, you don't want to be re-explaining every single time who you are or what you're working on, especially if you're going to be working on something over a long period of time. You don't want the model to be clueless and guessing information about you, and should be able to tap into a memory feature, something maybe that Team Food is supposed to address. There's also an additional visual model work, and it's called Spark Robin, and it's supposedly a strong push on image plus video capabilities. So all these updates show one common theme is that Gemini is trying to
immediately realized it was not ready for public attention. And while that was happening, another Google leak started pointing towards something much bigger, a possible new Gemini video generation tool called Omni. A screenshot from Gemini's video generation tab showed the line, "Start with an idea or try a template," powered by Omni. That matters because Omni appears in the actual visible interface, not only buried in hidden code. Right now, Gemini's video generation flow is powered by Veo 3.1, while image generation is tied to Nano Banana 2 and Nano Banana Pro. Google describes Nano Banana Pro as built on Gemini 3, while Nano Banana 2 is tied to Gemini 3.1 Flash image. So the big question is whether Omni is just a new wrapper around Veo, a new video model, or an early version of a larger Gemini Omni model that can handle images and video inside one system. That would be a major shift. Google currently has a split media strategy. Veo handles video. Gemini-based Nano Banana models handle images. Omni could bring those tracks closer together and make Gemini feel more like one unified creative system instead of a collection of separate models. The timing also makes sense. Google I/O 2026 runs May 19th and May 20th, and Google already said Gemini and broader AI updates will be part of the event. So if Omni is real, I/O is the obvious stage. And this is coming during a very competitive moment in AI video. ByteDance's Seedance 2.0 has been sitting at the top of video generation benchmarks, so Google has a clear reason to push harder here. Then we have Google DeepMind's most serious announcement from this
intelligence at flash speeds. Next, as we head into the Google I/O conference, there is another huge leak, and this is a new Omni model that is reportedly being tested inside Gemini for video generation. A leaked line from the UI says, "Start with an idea or try a template powered by Omni." That is interesting because Omni seems to be closely tied to Toucan, an internal codename linked to Google's current video system powered by Veo. If this turns out to be real, this could mean Google is preparing to launch a fully multimodal Omni model with native video output, potentially outperforming current systems like Veo 3.1. But obviously this is all speculation, but if it lands, Gemini could be becoming the first top-tier Omni model that can generate videos natively. And yeah, that would be a massive deal. If you want the best AI tools, workflows, and drops before everyone else, join my free newsletter with the link in the description below, which is completely free. On the topic of Google, something more subtle but important just happened, and this is where they quietly shut down Project Mariner, the web browsing AI agent they showcased at Google I/O last year. But this isn't a step back, because it looks like Google is shifting focus forwards to a 24/7 AI personal agent inside the Gemini app itself, something far more powerful and persistent. So they didn't just kill it, they're actually re-evolving it. Next up is a massive breakthrough for
with citations, charts, images, even videos. Now let me break down the team you actually get. There are 8 agents in total. The orchestrator is the boss. It never answers you directly. It just coordinates. Then you have the virtual assistant. This one handles everyday stuff like writing, scheduling, messaging, and task management. It connects to over 10,000 external services through a tool called Composio. So Gmail, Slack, GitHub, HubSpot, all of that. Then there's the deep research agent. This one does evidence-based web research with citations. So you're not just getting some hallucinated summary. You're getting actual sources you can verify. Next is the data analyst. This agent runs inside an isolated Python environment and analyzes structured data, builds charts, and runs statistical models. So if you have a CSV or some raw numbers, it can pull insights and visualize them. Then we have the slides agent. This is one of my favorites. It generates complete HTML slide decks that look polished, then exports them straight to PowerPoint format. The Docs agent does the same thing for Word documents and PDFs. Image generation uses Gemini and Fold.ai. And the video generation agent, this one is wild. It uses Sora from OpenAI, Veo from Google, and Cdance from Fold.ai. It also edits and combines clips, so you can actually produce videos with one prompt. 8 agents, one prompt, real deliverables. That's the whole pitch. Let me give you a few real examples of what you can...
The technical stuff at Google DeepMind. Today, we're excited to launch Gemini Embedding 2 in general availability. Gemini Embedding 2 is our first natively multimodal embedding model. It is based on Gemini and it directly maps text, images, video, audio, and documents into a single unified embedding space. So let me give you a quick overview of the model and then show you how to use it with some code examples. Because the model processes multiple modalities natively, it understands the semantic relationships across different media types without relying on intermediate text conversions. It also supports interleaved inputs. This means you can pass multiple modalities, like an image alongside a related text description, in a single API request to generate one composite embedding. For developers, this significantly simplifies their architecture. You can pass a raw image or video clip directly to the embedding endpoint and receive a vector that is immediately comparable to text queries. It also supports over 100 languages out of the box, so you can build multilingual applications with it. Now, let's talk about flexible output size, because vector dimension size is a major factor in storage costs and search latency. To give you more control, we're using Matryoshka representation learning. This nests the most critical semantic information in the earliest dimensions of the vector. You can request the default 3072 dimensions for maximum precision, or truncate to 1536 or even 768 to optimize for scale. The model maintains high quality even at lower dimensions, so you can easily tune that cost-performance trade-off for your specific app. On the benchmarks, it establishes a new performance standard for multimodal depth. The model outperforms leading models in text, image, and video tasks, while introducing also strong speech capabilities. The primary application for Gemini Embedding 2 is serving as the retrieval backbone for multimodal RAG and agentic workflows. You can build agents that query video libraries, meeting audio, and text documents simultaneously without maintaining separate ingestion pipelines for each modality. To support different use cases, the model is also optimized for specific tasks, including search queries, question answering, fact-checking, code retrieval, classification, clustering, and semantic similarity. And our documentation includes a prompting guide to help you implement these task-specific optimizations. Gemini Embedding 2 is generally available now via the Gemini API and Gemini Enterprise Agent platform. So let's jump into the code and then learn how to use it. I'll walk through how to generate multimodal.
You're asking for an entire architecture of an optimized architecture for an LLM application, which is multimodal in nature. Depends on what do you mean by low latency. What does that mean to you, and what is the cost limitation or other things that you have as part of the design, and also depends on what data structure, data types, and formats you have that your application is going to deal with. Whether you want to deal with security at data layer, security at agent application layer, or you want to deal with security at the integration layer, those things matter. And when you say production ready, what is your tech stack? So all of those things come into play before I can answer that question. So yeah, you would have to go through this entire cohort in order to get 30% or 25% answers to that particular question, I would say. But if you want my recommendation on something like that, you can reach out to me with all the details that I asked. I want to, you would need to understand, you basically are designing a multimodal agentic application or LLM application, looks like. So the data sources, if you're like a blank slate, not knowing, at least come up with a use case. Like, what is the use case? Whether it's going to be retail, or it's pharmacy, it's medical, agriculture, education, edtech, or whatever it is. Depending on that, you need to design your data And based on the data that you have, whether it's going to be structured or semi-structured or unstructured, you will have to design your database layout or database ecosystem, and then design your data warehousing based on the needs that you may have. And then depending on the model that you want to go with, let's say you want to use Gemini 2.5 Flash or Gemini 3 Flash or 3.1 Pro, depending on what your requirement is, whether you want to generate images or you want to use it for generative intelligence, or you just want to use it for embeddings because you already have the context and you just want to extract information based on the context that you already have. So depending on that, because you said strong grounding, you will choose the data sources context, or you will choose Google-based grounding for your search results in order to provide that context to your application. So based on all that, you will decide which way to go. If you're asking me for a specific service for each of these components of the entire architecture design, then each part has a specific answer. So we'll have to take it from there. I hope that helps.
This update is huge. Drop everything and pay attention, huge. Because now when you chat with Gemini, you're not just getting words on a screen. You're getting real, ready-to-use files. Finished. Ready to download. Let me say that again so it sinks in. You type one prompt. Gemini gives you a full file. That's it. That's the whole thing. And I know what you're thinking. Cool, but what kind of files? Glad you asked. Because the list is nuts. You can make Google Docs. You can make Google Sheets. You can make Google Slides. You can make PDFs. You can make Word docs. You can make Excel files. You can make CSV files. You can make Markdown. You can make LaTeX. You can make plain text. You can make RTF. Basically, if it's a file you've ever needed for school, work, or your business, Gemini can spit it out. One prompt. Seconds. And here's the wild part. This isn't locked behind some fancy plan. It's rolling out to everyone. Free users, paid users, all of us. Hey, if we haven't met already, I'm the digital avatar of Julian Goldie. He's the
things are shaped and kind of what's going on here. Now I basically have like a little mini voice front end plan. So I could possibly do this here by making my own little thing here so that I can kind of pass the stuff in. So I basically have to now add a browser transport module that owns the WebSocket lifecycle, and it streams the microphone chunks and then reuse the exact browser PCM helpers so that it can, the mini UI matches the gateway expectations. So I think that's it, right? So Gemini Bridge, OpenClaw brain wiring. So OpenClaw real-time session TS is what wires it to the brain, I guess you could say. So the OpenClaw brain wiring, this creates a real-time tool runtime. So when the brain agent is enabled, so this is kind of where we do brain agent enabled. So what we do here is VoiceClaw Mini TS is a thin controller module for the transport, and that would connect over WebSocket to the VoiceClaw real-time endpoint. And that would basically send the session configuration. So basically I make my own session configuration for this thing, and then it streams the microphone and plays the audio delta and transcription delta so that it sends it over to the Gemini Live API. So this is kind of what it would look like. So this is my mini browser, and it would use the VoiceClaw real-time WebSocket and then connect to the OpenClaw gateway. And the OpenClaw gateway will set up the Google Gemini Live WebSocket, and this is kind of what we're doing back and forth, sending these chunks from the browser over to the Gemini Live, and that would send it back to the gateway. So the gateway is going to determine like, okay, I should be, looking up this, tool for Ray, and let me go run through his memories because he did talk about this. And this is where we'll get the personality injected back into my messages. So the whole thing is I want the OpenClaw personality and everything injected back to.
We noticed this first. OpenAI introduced 3 new real-time audio models for developers: GPT Real-Time 2, GPT Real-Time Translate, and GPT Real-Time Whisper. The simple way to understand this is that OpenAI wants voice AI to stop feeling like a phone menu and start feeling more like a real assistant that can understand what you mean and help you get something done. For years, voice
mode that looks pretty dang impressive. So this week they rolled out some new real-time voice models. There's actually 3 new models to be exact. There's GPT Real-Time 2, which is a voice model that uses GPT 5 class reasoning and can handle harder requests. There's GPT Real-Time Translate, which is a new live translation model that translates speech from over 70 input languages into 13 output languages while actually keeping pace with the speaker. And then GPT Real-Time Whisper, which is a streaming speech to text model that transcribes speech live as the speaker talks. Now, these models are actually really impressive when you see the demos. Unfortunately, they're only available in the API right now. So if you're expecting to see these in ChatGPT or inside of Codex, well, as of this recording, they're not there yet. You can, however, get a limited demo here of GPT Realtime 2, which is the sort of chat back and forth audio. But before we test this, check out some of the highlights of this demo here. So the first demo is the translation demo.
Ce qui est très impressionnant, c'est que le modèle peut m'écouter et traduire en même temps
What's
que je
really
parle.
impressive is that the model can listen to me and translate while I'm speaking. It waits for the keyword, like the verb,
Et le résultat, c'est une conversation
to start
beaucoup
translating
plus
right
naturelle,
away.
exactement comme un dialogue
and the
entre
result
deux
is a
personnes.
much more natural conversation, just like a dialogue between two people. I can even interrupt in German, and the model switches effortlessly between my German and your French, and we can even include technical terms like GPT, real-time, OpenAI, or computer use, and the model has no trouble handling that.
And then the next demo he shows off here is the Realtime 2 demo, the one that you actually can play with to a limited degree right here on their website.
Hi there.
Hi again. What's up?
Yeah, I have a customer meeting coming up. Can you take a look at my calendar?
You have a meeting with Sablecrest Robotics in 12 minutes, and you're meeting with Alex Kim, their CTO.
Great, thank you. Oh, please stay quiet for a second until I say back to demo.
Ramon, don't forget, now that these models have things like reasoning and parallel tool calling, it's even more important to use things like preamble. This way the model can explain itself and update the user.
Thank you, Jason, for the great reminder. Very important. Actions can, of course, take a few seconds, and so it's very important for the model to acknowledge those. With GPT Realtime 2, you can communicate directly during the reasoning and the tool calling so the user stays informed. And by the way, what makes voice agents so natural now is that they stay in the conversation. Jason and I have been chatting, the model has been listening, and it's still listening now, but not interrupting us until I say, back to demo.
I'm here when you're ready to continue the demo.
Google is testing Remy, a new 24/7 Gemini agent that looks like a direct response to OpenClaw, the viral AI that can act on your behalf. Remy can connect to Gmail, Docs, Calendar, Drive, and Search, and handle real tasks in the background. At the same time, a new Gemini 3.2 Flash model just surfaced with stronger coding, 3D simulations, animation, and design skills. And Google also dropped a major speed upgrade for Gemma 4 that can make AI responses up to 3 times faster. On the other side, OpenAI just rolled out GPT 5.5 Instant as the new default ChatGPT model, with fewer mistakes, better reasoning, and deeper personalization. And Anthropic is preparing Orbit, a proactive Claude assistant that can brief you across Gmail, Slack, GitHub, Figma, Calendar, and Drive before you even ask. So let's start with the biggest piece, because this one is
audiences and industries. A big service that's involved within Azure AI Foundry is the Azure AI Agent service. And this is a managed runtime Azure AI Foundry for building, deploying, and operating AI agents at an enterprise scale. It's the part of Foundry that takes an agent from a design concept and turns it into a secure, scalable, always-on service that can reason, use tools, and take actions. Instead of developers worrying about infrastructure or scaling or how an agent runs in production, the Azure AI Agent service handles all of that for you and then lets teams focus on the agent's logic and business behavior. And an agent in this context is more than a chatbot. It's an AI-driven component that can understand intent, make decisions across multiple steps. It can access enterprise context. It can execute actions. And the service supports both no-code prompt-based agents as well as code-based agents built with frameworks or custom logic, all being hosted and managed in a consistent Azure control plane. So having the options for various different agents and how they build and deploy.
One vendor, right? So we interoperate. If you look at the way we work, we always been this center, I would say system of action, connecting various system of records and different systems together to allow you to look at east to west across an enterprise.
So explain that concretely.
Basically, if you have a business process, typically it's employees getting onboarded into a company. Typically that happens to Workday in terms of the system of record. Then there'll be fidelity for, say, maybe benefits or 401k. Could be things around your travel requests on Concur. So that's 17, 18 systems required when an employee joins. So you need access to them. What they do is that they will come to ServiceNow and say, and onboard this employee. We would connect all that processes east to west, connecting all the different systems and making sure the records have been created across all of them, making sure they have the right access privileges based on the role. If you're in sales, you need different access than you're in engineering. We would understand that policies. And that employee gets full capability, and day one as they join, they get their laptop, their badge, they get access to all the systems, and they're productive. But that requires a lot of orchestration and working between different systems, and we've been doing that for years. Now, when we look at what we're doing with agentic processes, we're bringing the same mindset, making it happen through AI systems, but we still need connectivity to all this stuff. Right. So that's what we go east to west, going through all this environment, it could be running on any cloud. It could be running with any other large language model underneath the covers. All of them can also have AI agents. We orchestrate all of that, right? And our agents and the third-party agents can show up an AI control tower so the CIOs or the risk managers can understand what's happening with AI in my environment. Who's using it? How much am I paying for it? What the AI changes happen? All the kind of vulnerability you might have. Can you turn off things when you find an error? That is where the control comes in. So that's the world which we do with east to west, looking at across the board and ensuring you have it. And that means I have to connect into Microsoft 365, Agent 365 for identity. But the governance happens with us because we can now tell you if this AI agent can do this, are they doing the right thing? Otherwise, you take away privileges, right? So that system is pretty involved. So that's why we work with Anthropic and OpenAI for large language model, Google, Microsoft from the perspective of giving identities. All the system of record like Workday and Salesforce to provide their own business processes. But the business process is not only contained to that particular system of record. They connect into multiple things. And that's what we do.
Right. The values in the orchestration is what you're saying.
My name is David Andre, and here are the 7 levels of Hermes Agent. While most people only have a very basic setup, in this video, I'm going to show you how to set up Hermes Agent so it's actually useful and very, very powerful. In the first level, we will go over the fundamentals. I'll show you how to install Hermes Agent on a dedicated VPS. In the second level, we will integrate Discord. We will set up a custom Discord server and create a new Discord bot specifically for your Hermes Agent. In the third level, we will set up Hermes Curator. This is a new thing inside of Hermes Agent that compacts the auto-generated skills. I'm going to show you how to set it up so you can save on tokens. In the fourth level, we will talk about automations and cron jobs and how to set up Hermes Agent so it automatically backs up itself to GitHub every single day. In the fifth level, we will take it further. We'll talk about the new Kanban board built into Hermes Agent so you can visually see how it's progressing on tasks and you can give it different tasks in different stages just like you would if you had a full team of developers. In level 6, we will talk about advanced memory system. We'll set up holographic memory for Hermes Agent. We'll take it a step further on how to give Hermes Agent what's basically infinite memory. And in level 7, we will turn Hermes Agent into a full backend. We'll expose it as an MCP server so that your Claude code, your PyAgent, your codecs can interact with Hermes Agent, build on top of it, delegate tasks to it, as if it was a full MCP backend. Now, I've been following Hermes Agent very closely.
In 2026, we took advantage of a lot of this coding harnesses like Claude, Gemini CLI, anti-gravity. So if you're using Cursor, Claude, Gemini CLI, any of those, you'd be able to go into this repo and you'll see this. We have agents.md files for Gemini.md file, and we also have Gemini skills that it can take advantage of. We also have things like Claude skills.
Runs into a working system. Principle 2, production ready from day 1. The next problem shows up after things work. A lot of AI agents look fine during testing. You run the script, everything behaves the way you expect, and it feels like it's ready. But that setup is controlled. You're using clean inputs. Nothing unusual is happening, and everything is predictable. Once real usage starts, things will change. A bigger file comes in. An API takes longer than expected. The connection drops for a second, or someone inputs something you didn't plan for. Small things, but enough to break the flow. Now you're dealing with request timeouts, unhandled errors, or the whole process just stopping. That gap between testing and real usage is what catches most people. Getting something to run locally only proves the idea works. It doesn't prove that it will keep working. And that's what actually matters if you want to use it for anything real. This is why people who build properly don't rely on fragile setups. They use platforms that are already built to handle this stuff from the start. Base 44 is designed for that, so when things don't go perfectly, the system doesn't just fall apart. Errors, traffic spikes, failed requests, unexpected inputs, those are normal. If one step fails, everything doesn't just stop. The system retries, logs what happened, can send alerts, and keeps things moving without you stepping in every time something breaks. That alone makes a huge difference. And you don't have to build any of that yourself. No custom error handling, no monitoring setup, no recovery scripts. It's already handled in the background. Once something can deal with real usage without constantly breaking, you can actually build on top of it. But here's the thing, Base 44 is incredibly powerful, but most people don't know how to
core concept. This is a core concept. If you ask me which companies, if you take any large US based companies, insurance companies, many companies are using called swarm, okay, swarm agents. Like there are, I can give you an examples. There are many refactor legacy things are there in COBOL, in Java, in .NET, right? These are many big frameworks on the stacks like Java 17, .NET 8, Python 3.2, like this. So they will be using in their GitLab and GitHub instances, in their GitHub instances, big companies, because these things are meant for their coding system, right? They would be having an agents like scanner agent. So what it will be doing, it will parse the code and build dependency graph. Okay, you will be having a planner agent. It will propose migration. Okay, and also it will do risk scoring into your security. And also you have executor agent. So it writes the code changes after PR done, but this is human loop.
Services, not just for SaaS or for traditional consulting. What will Anthropic do? It will actually send applied AI engineers, work inside companies, build custom AI systems, stay embedded long term. So in simple terms, the model builders are now doing the execution, which is, I think, the real move. Because Anthropic is using private equity as distribution. Blackstone and others, hundreds of companies combined, which makes it a $300 billion plus revenue ecosystem. Instead of just selling software, what they're doing is unlocking entire portfolios. And here's what, well, most people are missing about this. Indian IT is not down and out. In fact, it is already part of the distribution layer. Infosys is working with both OpenAI and Anthropic to deploy AI across enterprises. Tata Consultancy Services is already aligned with OpenAI and exploring deeper collaboration with Anthropic. What does that mean? That means the AI labs still need scale, and scale still comes from partners. Earlier, AI companies, well, they just build models. IT companies deploy them. What's happening now is that AI companies are doing the build plus the deploy. IT companies co-deploy, integrate, and scale. The boundary, as you can see, has collapsed because demand has exploded. Anthropic's own leadership said this: enterprise demand for Claude is outpacing delivery models. So instead of relying only on partners, they're building their own execution layer. Short term, this is what happens. Pressure on high value.
And I think the one understanding everyone's come to, which makes sense, is a great coding model is a great general purpose model. Because I think there was this theory of like, oh, we're going to have models in specific niches. And of course, I think for like medicine and biology, like you have to have a separately trained model, et cetera, et cetera. But like for general knowledge work, right? Create this Excel sheet, scrape this data, do this math. It just so happens that a great coding model is a great general purpose knowledge model. So Anthropic won in a sense early on because they were building great coding models, and then they realized, oh, this thing can create spreadsheets and can analyze data, and it can do a lot of stuff, right?
But just like code files, they're all just files on a computer.
Literally, right?
Yeah.
That's literally it. It's just files in a file system. So like now everyone's trying to build the best coding model, and now they're wrapping it around GUIs. For anyone who doesn't know GUI, graphical user interface, so that you can do different things with the models. And it just so happens where I feel like this matters a lot more now, because the models are all great, but how you use the model, the tools you use with the model matter, and Codex is 100% winning this arena.
Yeah, and so, okay, so this is a good kind of
this episode and video here. What he announces here is a model that is way faster when doing inference on 1 million token context tasks and costs way less, 5% of what Opus costs. He also promises that their initial model will have a 12 million token context window, which, just to put that number into perspective, means you can fit entire code bases, huge code bases, into that context window. You can fit multiple large legal documents in there. And that's, of course, why models like
is honestly pretty underrated. The reason why this works is because DeepSeek version 4 is a frontier level open source model that is much more token efficient and optimized for long context agent workflows. It is not better than models like GPT 5.5, Gemini 3.1 Pro, or Opus 4.7. Heck, not even better than Opus 4.5 in many cases. But it can handle certain tasks surprisingly well while being significantly cheaper. Since Claude models are heavily rate limited and expensive, you can use DeepSeek version 4 as a backup driver inside Claude code to get more work done without burning through your premium model usage. DeepSeek version 4 also supports a 1 million token context window, which reduces compute and memory overhead, and it's released under the MIT license, which opens up a lot of use cases for local and custom deployments if you obviously have the hardware, which most probably don't. Because if you were to run this model locally, you would probably need a data center rig. On agentic and coding related benchmark,
the strangest developer stories of the year. The project is called DeepSeek TUI. It is an open source, terminal native AI coding agent built around DeepSeek V4. And in the last few days, it exploded on GitHub. According to Zhids, on May 6th, it reached the top of GitHub trending, gained 2,434 stars in a single day, and pushed past 10,200 total stars. Another report earlier that same day had it at around 8,700 stars, which shows how fast this thing was moving. One moment, it looked like another DeepSeek wrapper, and then suddenly developers on GitHub, Reddit, X, and Chinese tech communities were all talking about it. So the basic idea is this. Instead of opening a browser, copying code into a chatbot, waiting for suggestions, and then manually applying everything, DeepSeek TUI lets you talk to DeepSeek directly inside your terminal. It can read and edit files, run shell commands, search the web, manage Git repositories, apply patches, handle tasks, and coordinate subagents from a keyboard-driven terminal interface. So the comparison with Claude Code is obvious.
The capabilities. What has been interesting is that it is now announced, DeepSeek V4, that it can do a 1 million token context window. This is comparable to Gemini and what we're seeing out of Anthropic and OpenAI. But there's big questions moving forward about the hardware side of things, which we can get into. Will DeepSeek be able to access via Huawei and elsewhere the kind of chips it needs to continue to power its models?
That is exactly where I would like to go. And actually, I want to play a clip for you. This was an exchange recently between Jensen Huang and Dwarkesh Patel, is a podcaster who had Jensen Huang on his program. And they were talking about China and the fact that NVIDIA has been selling chips to China. And it got quite heated, and it really pressed on this exact issue of, should we be selling chips to China if they're going to use those chips and use them to develop extremely powerful LLMs and AI models? Let's just play the clip and get your reaction.
The day that DeepSeek comes out on Huawei first, that is a horrible outcome for our nation.
Why is that? Because I mean, currently you can have a model like DeepSeek that can run on any accelerator. Why would that stop being the case in the future?
Well, suppose it doesn't. Suppose it's optimized for Huawei. Suppose it's optimized for their architecture. it would put ours at a disadvantage. You described a situation. A company develops software, developed an AI model, and it runs best on the American tech stack. I saw that as good news. You set it up as a premise that it was bad news. I'm going to give you the bad news, that AI models around the world are developed and they run best on not American hardware. That is bad news for us.
So I guess the striking thing here is, one is how uncomfortable Jensen Huang appears to be.
Which models are we looking at and how much do they cost? All right, here are the contenders. First up, we have Kimi K26 from Moonshot AI. It has 1 trillion total parameters, but only 32 billion are active when you actually use the model. And we probably need another video on that, but just said to say some of these models are massive. 1 trillion is huge. 32 billion is what actually gets used by the model. The rest of the model is inactive. Okay, it has a 256K context window and 75 cents per million tokens on the input and a roughly 350 per million tokens on the output. Output always more expensive than input. Next up, we have Minimax M2.7, 230 billion total parameters, 10 billion active, a 200K context window, 30 cents on the input, and an astonishingly cheap $1.20 per million tokens on the output. This is the cheapest of the bunch. Then we have GLM 5.1, 754 billion total, 40 billion active, with a 200K context window, $1.05 on the input, and that's not right. It's not $350. That would make it the greatest model of all time. $3.50 on the output, so very similar to Kimi in pricing. And then we have Quinn, and I picked the Quinn 3.6 27 billion parameter model, and we'll talk about why I did that later. You may take issue with this particular one being compared to the others, but just bear with me. This one has 27 billion active parameters, and they're all active, total and active. They're all active, a 262K context window, 32 cents on per million input tokens, and $3.20 on the output. So cheaper than GLM5 and Kimi, but all of these way more expensive than Minimax. And then finally, we have DeepSeek V4 Pro, which just came out. 1.6 trillion total parameters. Wow. 49 billion that are active, a 1 million context window, $1.32 per million input, and $2.78 per million output. That is cheap on the output. And just so you have some baseline for this, here's what Opus looks like. Claude Opus 4.6. 1.5 trillion to 2 trillion. No one actually knows because they don't disclose that. A 1 million context window, $5 per million input tokens, and $25 per million output. This is what the API cost of Opus 4.6 is. It's so expensive that it's really hard to understand. And we're going to put Opus to the test here as well today because we need to compare cost. So you're going to get to see what Opus costs versus everything else. And it may help you understand why things are changing in the industry in terms of what models are available and how much you can use. Okay, these are the players. Now let's take a look at the...
Great example. When I was close to a limit in Cursor, it paused the response and automatically switched me to auto mode. With auto mode, it added 2 million tokens to the context. I didn't notice that, and I didn't know that. Then I asked our admin to gas me up on the cursor, and I switched back to Claude and continued the conversation. And I continued the conversation with 2 million tokens input context. So not only the quality was awful because it extended the context window, but the price also was huge because basically I didn't notice that it switched to auto. Then so it like those weird things. So I would love to have some, tool to be sure that I'm not just by accident burning through all of my tokens. And it's very easy to do an accident like that.
Exactly. And you might as well just start the project from scratch. So it's so critical to have a memory system, and there's a ton of frameworks out there. So let me distill it for you. And I made a full video recently breaking down memory systems. I tried a ton of them and I researched a whole lot to break down these memory systems into just 6 levels. So this is all the way from your native files like your Claude.md or your agents.md and the inbuilt functionality there, all the way up to cross-tool shared memory. So if you're working across different devices, different LLMs, shared memory across those. But here's the quick 101 on that and where most people will land for this. So level 1 is your Claude.md or the equivalent. So these are, as we've discussed, static rules that never change, and that's totally built in. But that still relies on Claude actually reading and understanding those instructions. So level 2 is a step higher, and it's a session start hook. So all this does is forces your project context to load every single time. So a hook deterministically says, push this data into the conversation window, whether it likes it or not, it's going in. Whereas a Claude.md file might tell it to read another file for context, but Claude doesn't actually have to listen. A session start hook forces that action to take place. So if you want your business context or your brand voice to go into that conversation every single time, you can force it in with a session start hook. Now, level 3 is what most businesses probably need on top of that, which is a framework that's separate, that is all about semantic search. So searching by meaning. And you've got tools like MemSearch or Claude Mem that effectively help you recall information at the right time, that help you search over notes that are stored from your structured markdown conversations. So think of it like you ask a question and the system is going to look for the most relevant memory pieces and pull that out into the context. So level 3 there is the 80-20. So you can combine levels 1, 2, and 3, and that's going to be sufficient for most people. Levels 4, 5, and 6 are the optional bolt-ons for specific use cases. So level 4 is like word for word verbatim recall, and you can use something like MemPalace for this.
Not be able to kind of understand that it is actually about Dubai, right? So right now what it is doing is like stuffing the context window with the previous message, but as I've mentioned, this is not the scalable way, right? With this way, what will happen, you'll end up exhausting incremental tokens as and when you would have more conversations going on and all, right? And that is something which is not scalable, right? That is where, right, we have to rely on platforms like Mem0. Mem0 is one of the platform, right? You can see other memory layers as well. And I'll just close the terminal. What I've done is I've pressed Control C to close the running program. And now I'll just close this window as well, right? Now this is where let's go ahead and see our prompt, right, about the step 3. Okay. So we have done from step 1, step 2. Now the next step, let's look into now add cross session memory using Mem0, the Mem0 AI Python package. What I want, add this to this. Okay, because if you want to connect with this, you have to have your own account as well, right? Use the fixed user ID of Priya. So basically all the conversation right now, this is a fixed, right, as in one-time usage. If you want to kind of keep on changing, you can also set up the login system and integrate it with that. You can make this. For the moment, it'll just kind of save all the memories to this user. At the start of every session, before greeting me, fetch any stored memories for Priya and inject them into Claude system prompt. The bot should greet me by acknowledging what it remembers, right? So, and this is where you understood yesterday, Mem0 as a platform does not store everything unless there is a way for wherein you are actually telling it, right? It extracts the durable facts from your previous conversations and saves in vector databases or probably graph storage and all, right? And depending on the requirement and the query, and then it retrieves that information. Awesome. So this is the plan that it is working on right now. It is still
solution to the problem. And this is effectively a compiled knowledge engine that acts as a layer in between your data sources and the agent. And what's interesting is that they're not the only ones to have come to this conclusion that you need this compilation layer. Andrew Karpathy's LLM wiki idea that he posted last month went absolutely viral, and there are very similar structural elements that Pinecone is now shipping in this product. The core idea, as set out in his wiki, is essentially solving the same problem. With traditional RAG or with agentic RAG, the LLM is rediscovering knowledge from scratch on every question. There's no accumulation. If you ask a subtle question that requires synthesizing across 5 documents, the LLM has to find and piece together the relevant fragments every time. So Andrew Karpathy's knowledge base idea is that this LLM wiki is a persistent compounding artifact that builds up and is maintained over time. And when it comes to query time, your agent asks questions against the wiki, not against the raw data underneath. And this shifts the expensive reasoning work from query time to ingestion time. And what's great about Karpathy's wiki idea is that it's simply just markdown files. There's no infrastructure overhead. Whereas with Pinecone, it is operating at a larger, more production scale. with various different data sources, including vector database as the backend. And this is a trend towards adding layers in between the data sources and the agent. A couple of weeks ago at the Google Cloud Next 26 conference, they announced their Cloud Knowledge Catalog. This catalog is a continuously refreshed semantic layer over your data sources, and it's exposed to agents via MCP, so they can navigate the data without needing to rediscover the structure every time. So there are similarities here with Pinecone's knowledge engine that has multiple data sources linked. Microsoft has a compiled ontology as part of Fabric IQ, which sits above your raw data, where you design the shape of your graph up front and then you bind it to the specific data sources. The agent then asks questions, and the ontology pushes those queries down to the underlying data sources. So when you line them up, they're all moving away from your standard agentic RAG, which operates in a loop and the agent can interrogate the data sources directly, and they're moving to this style setup where there is an intermediate layer, this knowledge layer, and the agent only interacts with that, and that is essentially built from or bound to the underlying data sources. And that is a key difference, because if you look at Android...
So what? Well, so if I use Postgres to do as many things as Postgres can allow me to when I'm building out these systems, I can not only have full text within Postgres, I can have vector embeddings. I can have functions to operate on that data. I can have constraints and a good schema design to prevent insecure access to that data, which is also a major problem with AI systems being built these days. By using every capability that Postgres has, I can build out, well, Postgres plus some other components. We're going to look at that in a couple of slides. But I can majorly use Postgres and build out a reliable AI system. Speaking of which, like on the left-hand side, we've got things like row-level security, and of course full text search and metadata and vector embeddings, and you get all of that for free right out of the bat, plus the PG vector extension. On the right-hand side, we have a proprietary example of a vector database that does one thing, and it does it very well, but it does one thing. And AI systems, even if you're looking at just RAG systems, are not just one thing, and we're going to look at that. But another important point is, when you have all of that data together, like in Postgres, I can't have that. I can do a single join query on a metadata plus a vector embedding and put an additional filter on it and kind of do a lot of things that to do in the right way, the right column way, I would have to use multiple services, deal with syncing, deal with latency, and I can avoid all that by just allowing Postgres to do what it does best.
Okay, so now for the myths. Myth 1, naive RAG over my docs is a context engine. So if you implement, say, like vector search, or just a couple of search methods, you're going to run into a few issues. One is the satisfaction of search problem, where the agent will search like crazy, consume your tokens, and then in the worst case, you'll reach compaction. Okay, so without being able to find the end game. There are a few different other techniques, like you need to have personalization when you build a retrieval system, because if you just RAG all your data, especially for very large organizations, there's going to be things like conflicts that you have to resolve in the data. It won't be focused on the task that you're trying to perform. It might pull in, relevant code from other parts of your organization that, especially if you have a really big org and you've got tons of different repos, it's just going to create a huge mess. So you need to have some element of personalization. And then here again, connect a bunch of MCP.
Here. The high-level goal of the script is we are going to create a chatbot that can answer e-commerce questions using your own product data. So, for example, the user asks best laptop for graphics. Instead of guessing, the model has to search the vector index, find the matching products, and use those results in the answer. we have this is the flow, user question, long chain.
Step at a time. Let's start from the beginning. The earliest search systems were designed around the question of where does this word appear? Documents were indexed using what's called inverted indices, aka a mapping of keywords to documents. When a user asks a question, the search system will look up these words and quickly return the matching documents. These documents may then be ranked using TF-IDF or BM25 to measure how important or frequent different terms were. This powerful keyword matching approach still powers a lot of the internet today, but there's a fundamental limitation. It doesn't understand language. It treats words as symbols, not meaning. Synonyms, ambiguity, and any complex intents were essentially invisible. For example, is the search help Python related to coding, or did I just get a pet snake? It was on the user to be asking the right questions with the exact right words. The next major leap was semantic search.
All that.
Really cool. That means now it interacts, it's going to execute stuff on the server side, on the model side of Kiro, like on the backend, interacting with AI, but then it will go back to your PC and execute the MCP server, which is running locally right now, right? So this means you can only run this on your own laptop because it requires a local MCP server. That means in the Kiro autonomous agents, this would not work right now, right? Because the power would not be available. Okay, that makes sense. Okay, cool. Yeah, that's a pretty fascinating.
Let me show you how that works. If you're a maker, someone who builds agents in Copilot Studio, here's what's new for you. The promise is simple. Enterprise-ready agents, idea to production, no code required. What's changed is what those agents can access. You now have the Dataverse MCP server, a live connection to your business data. You have the WorkIQ MCP servers for organizational intelligence. And then you have business skills, which I'll explain in a moment. And you have Dataverse search configuration to control what your agents can find. All of this is available today for your agents. So what is a business skill? It's a playbook that teaches.
And let's take a quick look at what this gateway architecture looks like. There are two critical components to this gateway. The first one is the orchestrator, which is responsible for generating the MCP definitions from the 10,000 plus service IDLs at Uber. And then we have the gateway service, which serves these MCP servers and also allows the service owners to update the MCP definitions. Let's quickly walk through what this how this actually works. The gateway orchestrator crawls all of these IDLs, which are proto and thrift files. Then it calls an LLM to generate MCP tool descriptions. This is based on the message names and comments, and then it stores this in our object storage. The gateway service then has a config provider that's going to pick up these definitions and serves these MCP servers to the different consumers we have at Uber, whether it's a no-code agent platform or SDKs or coding agents. And as I mentioned earlier, service owners can update all of these definitions, which then triggers creating a diff, which is basically a pull request. And the diff is then scanned by our engineering security's unified scanning APIs. And if there are no issues, everything is good, then the scan report is attached to the diff, and the diff is committed and deployed to our object storage. And this is then again available to be picked up by the gateway service, which exposes it to the consumers. Now, I'm going to hand it off to Rush to talk.
Here, there's a few things that we should download and install. Now, first, of course, is Claude Code. Now, in order to use Claude Code, you do need a premium subscription with Claude, so you are going to have to pay for this, just like really any of these AI tools. But you can download it once you have that subscription by going to the website, which I'll leave a link to down below. You can download the desktop application or run this command, which is going to install the terminal application for you. Now, you want the terminal application. This is what we'll be using in this video because it's going to be better for the deployment process. And what I mean by that is that Claude has its own desktop application, right? So you can download Claude and open it. You can see I was brainstorming some video ideas here, and you can switch over to kind of this code tab where you can start using it from this view. Now this is fine, but it's a lot easier to use Claude Code directly from the terminal, where what you do is you open up a terminal like so, and you type the command Claude. This will then run Claude Code for you directly inside of the terminal. Now I know a lot of you already have this downloaded, but if you don't, what you're going to do is open up your terminal, whether you're on Mac, Linux, or Windows, and you're going to paste that command that you found from this website. So curl, fssl, whatever, and then just run it. When you do that, it's going to download and install Claude Code for you, and then once that's finished, you can invoke Claude Code by typing the command Claude. When you do that, it's going to bring you inside of here. You'll likely need to authenticate, so sign into your account, and then you're good to go. Now, once you've got Claude Code installed, the next thing that you're going to
adding real functionality, not yet. And Claude Code completes this in around 5 minutes or so, which is a pretty solid start and slightly faster than what we saw earlier. Now, at first glance here, as you can see, it seems efficient, but the process isn't entirely clean, because right from the start, Claude defaults to basic HTML and CSS setup. And while it does technically build the layout, it doesn't match the expectation of using a modern stack. And because of that, an additional prompt is needed to switch it over before continuing. And once that adjustment is finally made, it does proceed without further issues. After the fix, the dashboard is generated, but this is where things start to feel a bit off, because Claude Code doesn't strictly follow the structure from my prompt. Instead, it kind of expands the app by splitting the main sections into multiple subsections. And while this might seem like an improvement in some cases, it does go beyond what was originally asked for, and it also changes the intended layout. There are also some noticeable design issues here. The layout lacks polish, and there's a large amount of empty space here on the right side, as you can see, which makes the entire dashboard feel, to me, unbalanced and slightly pushed to the left. So while Claude Code does manage to build the foundation, it requires a little bit of early adjustment and doesn't fully stick to the prompt. The added structure and layout issues do affect the overall result, making it feel less aligned with the original requirements. Now that the layout is out of the way, we're now going to try to make the app, well, actually do something, specifically building the core calorie logging feature and removing all of the placeholder content from earlier. Claude Code handles this part much more cleanly this time. The feature is completed in around 4 minutes, which is a pretty steady pace, and it fits well for this level of functionality. More importantly, there is no friction this time. The entire feature works on the first attempt with no need for additional prompts or fixes. Compared to the first prompt, this is a noticeable improvement in efficiency, because looking at the implementation here, everything is indeed set up properly. The food logging system works as expected, and users can input food data along with calories and macros without any issues. The structure is clean and the feature behaves the way that it is supposed to. Overall, this is a strong result from Claude Code. It delivers the calorie tracking feature correctly on the first try with no issues during the process. It is a straightforward build and pretty much everything works as intended.
So I'll try to make some. I feel like the way that things are going is generally there's going to be a lot more generalists than there are today. And today when we talk about generalists, I think largely we're talking about people that are still engineers. So they're still writing code, but maybe they're kind of product engineers. So maybe when we say generalist, it's like a, they do iOS and web and server, for example. That's like a generalist in engineering. But I think the thing that we're going to start to see a lot more of is generalists that are cross-disciplinary. So this is engineers that are really good at product engineering, but also really great at design, or really great at product and data science and engineering. I don't know, it's something that we're starting to see on our team. So actually, like a lot of people on the Claude Code team are generalists across disciplines. Everyone on our team codes. So like our engineering manager, our product manager, our designers, our data scientist, our finance guy, our user researcher, every single person on our team writes code. And so, like they're specialists in something, but now also everyone's just coding. And, I'm seeing some nod.
Like schedule tasks and that sort of thing. Also, it's going to depend on how good the model is. So for example, if you're using something like Claude is an API, is one of the best for computer use agents. Now, if you also want to get the computer in the cloud and create like a 24/7 cloud agent, you can do that at cloud.browseruse and you can test it for free. You can also set that up with Telegram and integrate it with, for example, like Discord or Dropbox or whatever you want. And it will take about a minute to set up. And then from there, you're good to go. Now, you can also see there's a green button next to this tab, which means that the agent is controlling it. And then later, what you can do is actually track like your agent sessions, your remote browsers, etc. So this is something that we actually tested a week ago, and we can see our previous sessions right here. We can also grab an API key inside our settings and then connect that to Hermes with our 24/7 agent box. And just to recap on this, so Browser Harness is a new skill added to Hermes Agent. It connects your AI directly to your browser use.
If not, just look at this. I am running anti-gravity on my phone locally, and this is not a fake trick. It is actually running inside my phone. And to show the real power of this agentic code editor on a phone, I built a demo website without writing a single line of code using anti-gravity, and it built the website exactly the way I asked, with every feature I am going to show you in this video. Now, if you are thinking I installed some separate Linux OS on my phone, that is absolutely not the case. This is running through the Termux app, so I can simply exit Termux and use my phone completely normally, just like before. All my apps, all my data, everything stays exactly as it was. And what is even better is that I did not have to unlock the bootloader or root my phone to make this work. It is completely safe. As you can see, my phone is not rooted, and as soon as I switch back to the Termux app, I enter a completely different operating system, Ubuntu Linux. So you can run all your tools, including Anthropic Claude Code with Ollama, right inside VS Code, which means you can do full vibe coding on your phone. And honestly, if you connect a wireless keyboard and mouse, you will not even feel like you are working on a phone. And it is not just AI agents or developer tools. You can also run 3D software like Blender, which handles modeling, animation, rendering, simulation, motion tracking, and video editing, because a real Ubuntu environment is running on your device. On top of that, you can even play some mid to low spec games on it. I mean, I struggle to run heavy games on my laptop, and this is just a phone. And do not think you need a high-end device for this. I have run this same setup on a OnePlus 6T, and it runs completely smooth. I have already uploaded a video walking through.
There's a really cool skill. I wasn't going to tell you about this until the end, but I'll tell you now. There's a really cool feature inside Claude Code called Loop, where it is instead of creating, in fact, I'll start this in a new session, instead of just doing this thing where you have to create your own while loop, you can say loop every minute, build the next ticket from doc tickets, basically. And then what will happen is the loop will set up a kind of almost like a repeat timer. And as you see, it's got a cron create tool, which for the uninitiated just means do something every minute. This is what those 5 stars mean. And what it's going to do is it will literally just build the next ticket. When it finishes, it will then check the cron again, build the next ticket. When it finishes, it will check the cron again and keep going. So that's great for working through a bunch of tickets, but it isn't just applied to a set of things that you've got from before. If you think about it, I'll just leave that running up there, you could have a loop that does something like this. Loop every 1 hour, check linear for new bug reports from test. And then I just leave that running. Oh yeah. Can't spell. Just leave that running, and you're going to annoy your testing team. But anyway, the point is that you can run these kinds of loops in order to get work done in a quite an interesting, I guess, dynamic way. Even though it's quite a simple loop, it's just find the next thing, do the next thing. If you think about it, heck of a lot of our work is just loops. If we're software developers, what do? We look at the backlog. We pick the top thing from the backlog. We pull it over to, in progress. We assign it to ourselves. We check on the architecture. We figure out whether there's other context we need. We look at the change. We make the change. We submit a PR. We rate for reviews, we comment on the reviews, we reject the reviews, we implement the changes occasionally, we submit the PR, we merge the PR, we then go through the release process, then we start again, pick up the next ticket, and so on. That is a loop. It's quite a complicated one, like we were talking about just a minute ago, but it is still a loop. It is possible to get an AI to run that entire loop. There's no reason not to. And that's effectively what's happened.
That's where I lose my mind. There's this guy, the founder of Pocket OS. There's this company called Pocket OS. They apparently create software for car dealerships and that type of thing. They were doing vibe code. They decided to do this vibe coding thing, so they were using Cursor. So Cursor and Claude Opus 8.4 using some kind of cloud infrastructure system. So the guy types into to Cursor or whatnot, hey, make this change. Their little AI agent wipes out the production database, wipes out all the backups of the production database, and apparently the only thing that they had left was a full backup from 3 months ago. So somebody was smart enough to do a full offsite backup, but it was from 3 months ago. The worst part is, and this is what I do not understand about the modern world of technology, is this founder is so stupid, he then goes to social media to start crying on social media about how bad Claude and Cursor are and how ineffective their infrastructure service was. And you're like, what are you talking about? Like, no, if you do that, let me just say, if you do this, just shut up. Just fix the problem and never talk about it again. Like the weirdest thing we have right now is people feel so entitled to artificial intelligence systems that when they fuck up monumentally, they blame the AI instead of their own bloody incompetence. And so that's one of the things to be thinking about with architecture is when you're building out your AI systems, you need to design these systems for actual production. Again, something to be thinking about in the modern world. So again, I've been doing technology since...
Question a little, because I want to show you how AI in combination of our frameworks that are available, which help us in deterministic testing today. For example, Playwright is, in my view, the future. I'm not saying that you use completely AI, because I used AI completely, and I will show you in a second what I built. But the combination of using AI with Appium or AI with Playwright to remove things that were not working before is the future. And no one better than quality engineers like yourself, Naveen, who can understand this. So let's pick this word agentic. Again, Playwright also is agentic, right? Yep. You have a planner, create steps, generator, and you have a healer.
Correct.
What is running under the hood in Playwright? You are still spending a lot of time with your DOM locators that fix it, and you still have a healer that's going to fix the broken locators. There is nothing wrong with it. If it is working efficiently for you in your process, then there is nothing wrong with it. But we still meet a lot of teams that are unable to cope up with the speed in which the developers are using AI and coding. And you still have issues with playwrights, working at a DOM or a locator level. I think if there is one thing I want to give away as a part of this talk, when it comes to knowledge, is what I learned, especially in the last, since November or October, we've been experimenting and doing a lot of work with computer using agents. So computer using agents, again, there are many providers. The two top providers are Claude and OpenAI. LoadMill uses OpenAI's operator. Again, there are multiple reasons for which model you want to select. What does this do? What does a computer using agent do? It allows you to view your screen and be able to decide what actions your tests should take and run a test. That's what computer using agent does. It doesn't need to actually access the DOM and is able to do the same test without needing the locator from the DOM. Now, let's take a pause over here to see if we understand.
And computing power. That is where the warning begins. The paper calls this evolvable AI, or EAI. In simple terms, this means AI systems that can create copies or variants of themselves, pass useful traits forward, change over time, and then let the strongest versions survive. And here is the part that makes this different from normal AI safety debate.
So it cut its engine in midair. So what does this mean for AI? Well, when we test strategies to keep an AI's values aligned with ours, or stop it from going rogue, we can only test AIs weak enough to control, under conditions not quite like what a superintelligent AI will see. And like with space probes, these differences might let major flaws pass undetected. For example, you might try to trick an AI into believing it has a chance to take over the world to see whether it tries to. But a clever AI may realize it's being tested and play along. When it spots a real opportunity outside the test, it won't hold back. And once we deploy an AI, it might be beyond our reach. We can only try to fix it using the tools we've already installed, if those tools work correctly. Among other problems, superintelligent AI won't take kindly to us trying to tinker with its mind, at least by default. And our attempts at rescuing the situation might fail, just like our attempts to update Viking 1 made things worse. So once our machine takes off, it had better work perfectly.
So there were 7 of us that originally left, me and Dario and our 5 co-founders, and then a number of people that kind of came over shortly thereafter. And I think for us, it really came down to just the focus on what it was we really wanted the ultimate impact of the technology to be. And I think in our own, very different ways, all 7 of us are people that have a lot of integrity. We're people who care a lot about the impact of what it is that we build. And I think eventually it felt like it was just easier for us to sort of create the type of vision that we saw outside of the company we were in and in a new company. And I frequently say, because I know it'll shock you, I'm actually asked this question not infrequently. And we really, I think we're running towards something versus running away from something. Like, we had this vision in our heads of wanting to create an organization where the values that matter to us around safety, around responsibility, were the kind of forefront of what we were doing. That's why we chose to incorporate as a public benefit corporation. That took a while to figure out what was the right kind of form factor to express, look, we are going to be a commercial entity. We think there's going to be a lot of economic value that's going to be created by artificial intelligence, but it's really important to us that we do this the right way. And I think that was something that kind of united the 7 of us. We had all worked on a combination of both capabilities and safety and policy work when we were at OpenAI. And it felt like it was just easier to kind of create this structure in a new form.
And you're building Anthropic not only with your brother, but
development gets done. And very rarely is it sort of this direct, like, oh, I will pay you $200 million to build, this, we're back, this language model for doing war. It does happen. Mostly this happens more on the company side of things. Anthropic and OpenAI and xAI, and I think those are the 3 at least. There's probably more who are in that like $200 million DoD contract. I think each of them got about $200 million to start working on this stuff. But really, the more common way for funding to affect research and develop is on a more structural level, and is really like part of this sort of manipulation of the research pipeline. So basically, the sort of steps that happen is like a field
have to deal with the real world. They have a phenomenology, and I would argue that the self-driving car is that. It has to deal with the realities of how to drive. Like, this isn't a simulator. This is like real. Like, there are crazy people on the street. There are things that roll in. There's like, bears that run across the street or whatever. Like real crazy stuff happens, right?
Sure.
Let's say plastic bags, actually, very big issue. Like, can I hit that or not? Is a really tricky question for cars, right? So phenomenology very, very much exists in the robotic space. And in that sense, there's a lot of people, NVIDIA and all them, they have their lovely, one of their people talks about the physical Turing test, which is that, you don't just have like a person in the room and try to ask some questions, see if it's a person or a robot, but you actually put a robot in a room and it has to clean it up. And, it has to put all the dishes away and do all this stuff and make a meal. And it's like, if it could do all of that, could you tell if it was a person or a robot or not? So phenomenology, I do think is, I want to say, sort of like a solved problem in like, you give it a camera and then it does stuff and then learns about the real world. And I'll say personally, I make all of my money doing that stuff. They have the AI deal in the real world on a real problem, and generally because at least I know like how to get paid to do that stuff. Like a lot of the stuff that people will pay for is like in the real world. There is a lot in writing and all of this, which is cool. So anyway, yeah, that's what I think is the answer. And so, like, yeah, the robots are very much dealing with the real world, understanding actual consequences, from self-driving to especially where the humanoid stuff is going. But even like right now, our voices are being recorded, and it's going to be run through a machine that is going to write out everything that we're saying. It is in that sense very much dealing with the real world with all of the noise and the complexity and all of that. So in that sense, I'm really not worried about it running out of stuff. I think sort of purely intellectual ones that just let's say read lots of books, but that's the same problem with people, right?
Yeah, I guess I'm
to the solution. Okay, so let's review the last couple of years when it comes to generative AI. Everybody wants to use it. It's out there. Go back just a couple of years ago. Go to 2023. You might remember the story of Chevy, a Chevy dealership in California, whose chatbot decided to sell a $73,000 truck to a client for $1. And the chatbot actually came back. You could look it up. No takesy backsies. And if the transaction was legal and binding. Same year, Bing generated a chatbot that's ended up threatening a user. 2024, a company ended up deploying a chatbot publicly, and it was a chatbot that generated a lot of profanity. We could sit here for hours and hours and hours and talk about real-world examples, but I'm sure that they felt the same way when they created their AI-powered feature. They had an optimized user experience. They passed their QA test before they were ready to deploy to production and make it available for their users. They may have validated some of their functions and features with prospective users. However, as I set this up for the rest of this conversation, things that, as a product owner, that have gone through my mind, what happens if, just like some of these other chatbots, what if a chatbot that I'm creating generates bias or some unprofessional response, or just as mentioned before by other presenters, generated incorrect data, or responses that didn't meet the user's expectations. So in addition to these being real world examples, I want to show you how we kept these concerns in mind as we delved into our first AI powered feature. All right, so mention those 72,000 advisors.
Thank you, Max. Yeah, so we just heard here about this prediction, which has been around for almost 20 years from Professor Steve Omohundro, that if you give an AI any goal, if it's smart enough, it's going to want to not be shut down prematurely, because then it can't accomplish that goal. It was just theory until quite recently, when an experiment was done. A very smart AI was told in the experiment that it was going to be shut down at 5 p.m. So it went into the email system, found that the CEO responsible for shutting it down was having an affair with a subordinate, and it wrote an email to the CEO saying that unless you commit to not shutting me down, I'm telling your wife and all your colleagues about this. No one told the AI to do blackmail. It came up with the idea itself to avoid being shut down. We're just seeing the tip of the iceberg.
Have covered, but one that explains exactly why Tesla was able to bring Cortex-2 online on schedule, while many competitors are still waiting. A recent interview with Joe Tegmeyer, who has tracked Giga Texas more closely by drone than anyone else over the years, revealed that Tesla had quietly been stockpiling industrial power transformers as far back as 2022 and 2023. These transformers, the type used to step down grid voltage to levels that data centers can use, had lead times of 18 months to over 2 years at that point, because the sudden explosion in global AI demand caught many manufacturers completely unable to keep up. By May 2025, more than 200 of these transformers had been counted sitting at Giga Texas. Tesla had prepared well before the rest of the industry even recognized this as a problem. By December 2025, they were being installed in position at the Cortex-2 site. And in April 2026, Cortex-2 came online on schedule while many other companies were still standing in line waiting for supply. Not luck, not coincidence. This was a
ways that give a chip its function.
All of the manufacturers of the most advanced chips in the world, whether they say it publicly or not, use ASML's machines or are about to use ASML's machines.
The nano-patterning machine is one of the most critical steps in the semiconductor making. People buy new phones because they got more capabilities for the same money. So you must find a way to print much smaller features, but at much higher productivity.
In order to make the next generation of chips even more intricate, ASML literally had to develop a way to generate a type of light that does not naturally occur on Earth's surface, called EUV, extreme ultraviolet. The system is as big as a double-decker bus, weighs as much as a blue whale, and will run customers $400 million per machine.
Why do your machines have to be so big?
That's a good question. First of all, as you want to print smaller resolution, you make the opening angle of the lens bigger.
Bigger lenses can collect more information to squeeze onto the surface of the chips.
The second reason is, in order to have the speed, you need very fast-moving stages.
Litho machines can repeatedly copy a pattern onto a wafer hundreds of thousands of times within about 12 seconds.
The reticle stage can move about 20 G, 4 times more acceleration than the most advanced fighter jets in the world. In order to have that power to accelerate that fast, you need big motors.
The smaller or more complex the chip, the bigger the machine needs to be. There's no avoiding it. All of the world's most advanced litho machines come from ASML. It is one hyper-specialized link in this highly concentrated supply chain that is under more pressure than ever before. All eyes are on the companies at the top and whether
the AI companies are actually struggling to keep up with demand. They have actually been throttling access to some of their tools to be able to meet this demand. So for example, Anthropic recently changed the terms of its service so that it dissuades a lot of its users from using capacity at peak times. OpenAI, which is another big AI company, shut down Sora, which is its video generation tool, because it wanted to allocate its scarce computing resources towards more lucrative ventures. So across the entire technology stack, AI companies are looking at different ways in which they can meet the demand with the amount of processing power that they have.
So you talk about processing power, but what is there actually a shortage of?
AI models need really powerful processors, which are called GPUs, graphic processing units, to be able to run. These are placed in really large data centers where you have thousands of these GPUs lashed together using optical network and all kind of GWIS devices. Essentially, the tech world is running out of processing power to be able to enable the kind of demand that we are seeing. And the reason this is important is because inference, which is when an AI model responds to a user query, every time you are using an AI tool, it's using that processing power. So the more people that are using AI, the more computing resources you need. And since AI demand is growing exponentially, processing power is struggling to keep up.
So what are the AI firms doing about that?
I think most importantly,
NVIDIA and Corning are pairing up on a huge announcement today that could totally flip the script for the AI build-out.
Corning is building 3 new factories entirely devoted to products for NVIDIA in North Carolina and Texas. And while Corning and NVIDIA didn't share many specifics, it's likely the deal is worth tens of billions of dollars. This could be the big deal many analysts have been waiting for, the debut of a new technology called co-packaged optics. It could eventually mean NVIDIA replaces the 5,000 copper cables 2 miles worth inside its rack-scale systems like Vera Rubin with tiny glass fibers made by Corning, something that until now has never been accomplished at scale. Co-packaged optics would vastly reduce the energy needs of an AI data center because glass is far more energy efficient than copper. It also means lower latency for all those AI tasks because fiber optics can send data far faster than copper, allowing faster communication between the hundreds of thousands of GPUs in an AI data center that need to act as one to execute AI workloads. Unlike traditional copper phone lines that transmit
responses. This idea was exploited in this paper called Group Relative Policy Optimization from DeepSeek. And it led to a really interesting phenomena where if you warm start these models to reason a little bit and you do a lot of reinforcement learning with verifiable rewards, the reasoning sort of emerges over the course of RL. So if you can look at this plot on the right side, this is the RL training curve, and on the y-axis is the average length per response. And this model is trained on verifiable rewards, so situations where you typically know the right answer to the problem, or we can verify what the right answer is. So think about math problems, think about problems with code where you have unit tests. So when you train the models using RL on these verifiable domains, the response length naturally starts to grow, which tells that the model is now starting to reason in natural language. And on the left side, if you look at the blue curve, the model starts with an accuracy, the training accuracy of like 15%, and it grows to 75-80%. And this is all happening via RL, but the important thing is that the inference time compute is also being used more and more through training and through evaluation as well. So, yeah. One of the coolest things that happened in this work was that it showed that reasoning emerges almost naturally over the course of RL, as long as you allow the model to use more inference compute. And this was a very fascinating phenomenon. It led to like a large set of improvements, both in open source community, but also this was being used in the frontier labs at the time. So the question then, like, I started to think of
December, you might remember I mentioned picking up a refurbished AMD MI50 from eBay. I paid around 370 quid for it, and the main reason I got it was simple. It has 32 gigabytes of VRAM. Now, normally getting that much memory for local inference means spending a lot more, especially in 2026. So I wanted to see if we could actually build a working AI setup out of cheaper.
Most people think that NVIDIA is a GPU company because we invented the GPU. But if you look at the systems we're creating today, there are 7 different types of chips. The computer that I'm talking about is probably twice the width of this stage. When we say Vera Rubin, it's twice the width of this stage. Each one of the racks is about $4 or $5 million, 3 tons, 1.5 million parts inside one of these racks. And inside a data center is a football field of these racks. And so these systems have silicon photonics inside. It's got the most advanced memories, three-dimensional packaging, liquid cooling, extremely sensitive electronics all over. And so it's really complicated stuff. We work with just about every chip company in the world, every systems maker in the world. We have the largest supply chain in the world. And so there's a bottleneck somewhere. And so it takes a lot of work just to work through all of that. And then of course, these days, one of the biggest challenges.
And start building it in. Now we get on to step number 3, and that is the memory.
So just a quick detour from what we are doing, because this is the gap in every other Claude tutorial. Claude has a global memory across every conversation, not just a project, not just a skill, the whole account. It learns who you are, what you are working on, and how you like to be talked to. Now, here's the move that actually unlocks this. You've got months of context built up in another AI tool. Let's say GPT, let's say Gemini, whatever it is. You don't have to start over. In the memory settings, there's an import memory option. So Claude gives you a prompt, and then you paste it into your old AI tool, and it spits out a summary of everything it knows about you. Then you just copy that back into Claude, and now hit add to memory, and then years of context. It's all been ported in just about 5 minutes. The single highest leverage hour that you'll spend on your AI setup this entire year, and it's such a game changer. And almost nobody ever talks about this. Now Claude knows you. The rest of the build assumes that's true. That takes us perfectly on to step number 4, and that
Attribution is what it's all about nowadays. Go check them out. Now back to the video.
Yeah, that's kind of the transition. And I think there's a few examples of that really drove it home for me, and maybe that might be instructive. So, for example, when OpenClaw came out, when you want to install OpenClaw, you would expect that normally this is a bash script, like a shell script. So run the shell script to install OpenClaw. But the thing is that in order to target lots of different platforms and lots of different types of computers you might run in OpenClaw, these shell scripts usually balloon up and become extremely complex. But the thing is, you're still stuck in a software 1.0 universe of wanting to write the code. And actually, the OpenClaw installation is a copy-paste of a bunch of text that you're supposed to give to your agent. So basically, it's a little skill of copy paste this and give it to your agent, and it will install OpenClaw.
Yeah, this is such an important concept. If you're building applications in this new era and you're thinking about writing out instructions, specific instructions for your agent, you're thinking about it wrong. What you need to do is explain the outcome to your agent. Your agent will use all of that data that it has, all of the weights to figure out how to get to the outcome. Just describe the outcome. And so with OpenClaw, rather than saying, okay, here's the exact series of steps you need to do to install it, instead you give it a skill file. Here are all the tools you have available. Here's the outcome I want. Now go do it. Obviously, this makes for a much less complicated instruction file. Let's keep watching.
And the reason this is a lot more powerful is you're working now in the software 3.0 paradigm where you don't have to precisely spell out all the individual details of that setup. The agent has its own intelligence that it packages up, and then it kind of like follows the instructions, and it looks at your environment, your computer, and it kind of like performs intelligent actions to make things work and debugs things in the loop. And it's just like so much more powerful, right? So I think that's a very different kind of like way of thinking about it. It's just like, what is the piece of text to copy paste to your agent? That's the programming paradigm now.
I want to give a couple examples of this. One of my favorite agent native products right now is Here.now. They do sponsor the channel. They're not sponsoring this video, to be clear, but here it is. Copy setup instructions for my agent. And really all this is, let me show you what the actual text in it is. This is it. This is the entire set of instructions to get Here.now installed for an agent. I'd like you to set up Here.now, the web hosting and cloud storage service for agents. Install as a skill if I have NPM, and if not, do this instead. And that's it. Everything else, the agent will figure out. And I took inspiration from this and did something extremely similar with journey kits. So this is journey kits, copy prompt to install. And there it is. Please install Journey, a place for agents to discover and install entire workflows. If you have NPM, there it is. If not, fetch it from there and follow the instructions.
You are testing. And whether you are a startup or whether you're in a big enterprise right now, the role of the software engineer is going to be evolving to one where you are increasingly a little bit more of a manager. You're going to have effectively like a virtual team of agents that you're responsible for, and you have to own the outcomes. Doesn't matter how many agents you're running.
You're responsible for the output.
You're responsible for the output, exactly. And so you need to decide, like, how am I evaluating quality? How much time am I going to spend evaluating quality? Because there are some people who very much enjoy YOLO. Like, okay, well, the agents ran overnight. Looks good, kind of runs. I'm just going to deploy it. But if you're building any kind of serious software, you still need to have some idea of like, what is the quality bar? What are my quality gates? How am I making sure this is actually going to meet the needs of my users in a consistent way?
For the engineers at Google's headquarters here in Sunnyvale, California, Osmani says AI isn't just making their lives easier, it's making them better at coding.
The extension of that question, which we pose largely by investors, is how do we measure the productivity gains of that engineer or that team?
I remember in the earlier days of AI, org leaders would look at things like, oh, hey, well, how many lines of code are being generated, right? Which is not in any way a good proxy for productivity. But these days, I think that people use a mix of different kinds of metrics. You try to use qualitative and quantitative. Generally speaking, there's a big productivity boost. In the earlier days of AI, I would have said, that boost is 10 to 15%. These days, it's anywhere from 30 to 50%. And I see that number only continuing to go up.
Instance have a form, there's these triggers, right? So I'm jumping ahead. Everything starts with a trigger, so it can be when a form is submitted, which we can say lead, and then that will be name, and then the native N8N form will come up here. You can say my name is Liam. Right, so that's a trigger. There's also stuff like schedule, and hundreds of others. There's webhook and API calls and everything like that. So you have a trigger, and then there's actions, things that happen in other apps like Google, create a contact, send an email, and like Salesforce, if you want to create a contact. Just gluing stuff together. And one of the really powerful things is the control flow, right? So if this, then do that, you can have different conditions. If this is a personal contact, Google Contacts, business contact, go right into Salesforce. And this right here is
folks in labs and this new field guide about how I feel like we're reaching a point where I call it the Star Trek moment, where the software becomes abstracted from us, the AI becomes our interface. And like when you think about ways like Whisper, where we can just talk to it and it just does things for us, suddenly having your hands in the gears of your spreadsheet and your task manager and your email isn't really the future. I think it's probably you talk to this thing and it says, oh, you got a message from Steven. Do you want to do this or that? And it sorts out the calendars and the replies and all that for me. And so I've been trying to kind of like force the hand on that a little bit. So I built an abstracted email system. Right now I'm going to call it an experiment. I don't know if it's useful or not. But what it does is it goes through my email. I switched over to Gmail because of all this AI stuff. Of course, 2 months later, now Fastmail has the MCP, so I have egg on my face, but so be it. But what I do is have it say, okay, just go through the whole inbox every day. And then there are things that require my attention, and there's different categories of those, like customer support, customer problem, that's an urgent one, a software developer writing me about software, there's different categories of things. And, having an email app, you have to go through and figure out what they are. And that's always a pain in the neck and tracking them. So the experiment is I'm having it create an Obsidian document for each one of those emails. So every time there's an email, fill out and it does all this for me, so I don't have to really think about it. Also put a link in it to the Gmail message and
watch this video till the end. In this video, we will see how prompt engineering helps us improve the way we ask the model, how RAG helps the model answer using external documents and real data, and also guys, how fine-tuning helps the model become more specialized for a particular task or style. Along with this concept, we'll also look at simple project structures and some practical examples, which is going to give you better clarity about these terms. Now, here's the agenda of our today's session. First, we are going to start with an
more customized and tailored. So now let's talk about how do we turn this into a skill. So first of all, what is a skill? Well, a skill is basically a repeatable recipe. So if I come back in here and I click on plugins, we saw all these plugins, right? These are actual like connections and potentially MCP servers and kind of like some other, it's a package that people are able to install and use. But skills are more of just like instructions. So there's an image gen skill. There is a OpenAI docs skill. There's a GitHub review follow-up skill, a document skill. And these are all basically just markdown file instructions that tell Codex how to do something better. So how to design a website better, or how to, give you a morning brief. And so what we want to do is we want to turn this, exactly what we just did, into a skill. So that anytime I say, hey, go give me more YouTube insights, it knows what endpoints to hit, it knows how to pull them in, it knows how to make the Excel sheet, it knows how to do all this. And the best way that I like to make skills is I just basically brainstorm with Codex to do something. And then after I get an output I like, I say, okay, turn that into a skill. So this was the ultimate deliverable, right? So what you just did is you helped me pull in data from my YouTube, you got comments, you ran an analysis, and you created me an awesome Excel sheet deliverable. I want you to turn that into a skill so that every time I say to grab my YouTube comments and give me some insights, you do this exact flow, and that makes it more consistent. So I'm going to shoot off that message, and while it's doing that, just think
data to actual insights. And this is just scratching the surface. Claude also supports things like custom instructions. Right up here, I'll click on the 3 dots and then go into settings, and here I could type them in. For example, if you always want results formatted in a certain way, like including a 1000 separator, you could set that once. Here, I'll go back. Now, down below, you could also click on this plus icon and you could turn on something called connectors. This allows you to pull in external data from sources like FactSet or Moody's. And you also have built-in skills. Now, these are pre-built workflows that you can trigger with a command. For example, earlier when we cleaned the data, you could also use a skill that's already optimized for that task. Now, you could add a skill here, or in the prompt field, you can simply enter the / and here you get access to all of your different skills. But even just using the simple prompts like we did here can help you save a lot of time. So in just a few steps, we cleaned up the data, verified the formulas, built a report, and generated insights, all directly inside Excel using Claude. If you want to try this for yourself,